Hello children, we are doing class 12 mathematics, chapter 6 application of derivatives, miscellaneous exercise, question number 18. Show that height of a cylinder of greatest volume which can be inscribed in a right circular cone of height small letter h and semi-vertical angle alpha is 1/3 that of the cone and the greatest volume of the cylinder is 4/27 pi h cube tan squared alpha. So here given data is the cone. In that one we are trying to fit many cylinders. So you want to find out the maximum volume of the greatest volume of the cylinder that can be inscribed in a right circular cone. So here we'll write the height of the cone. Height of the cone they gave. Cone. Cone was the given data. So height equal to height of the cone was small letter h. It was given. Since it was a given data, it is a constant. Now radius of the cone. Radius equal to r. That one also was a given data, so it is a constant. Now about the cylinder. Let the height of the cylinder, or let the height equal to capital H. Let the height equal to capital H. So height of the cylinder we took df. In the same way, for the height of the cone also I'll mention that one, AF actually, AF. Put a small letter h. Now radius of the cone, that is FC. That is small letter r. Now let the height of the cylinder, I'll take df. Where is h? H unit it is. So that will be equal to, that is df equal to h. Now next one, radius of the cylinder we are assuming as capital R. Radius of the cylinder we are assuming as capital letter R. Capital R. That is d equal to capital R. Now we want to prove that the volume of the cylinder is maximum. Volume of the cylinder is maximum. For that one, first we will take the similarity between the triangle ADE and AFG. Triangle ADE is actually similar to triangle AFG. Triangle AFG. Because each angle is 90 degree and this angle alpha will be common. Therefore, AD divided by full AF equal to DE divided by full FC. One more data, AD are not written, AD equal to, total was capital H, so AF minus DF equal to, total was AF was small letter h minus DF is capital letter H. Then anything more? Not that much way. So here now we'll start AD. AD is small letter h minus capital H divided by AF. AF is full thing, that is small letter h, equal to DE. DE is capital R divided by again FC. FC is small letter r. Here small h and small r are constants. So we should make either capital H or capital R alone. So in this one, I'll make capital R alone. So I'll cross multiply. So small h minus capital H into small letter r into capital H, capital R into small letter h. This one will make capital H alone because volume of cylinder, I'll write the formula on one side. Volume of cylinder V equal to pi, radius of the cylinder is capital R squared and capital H. So here power of H is only 1. So it is easy for you to make H alone. So I'll make H alone. So open the bracket small r into H minus small r into capital H equal to capital R into H. Or you can divide also H by H minus. In that way also you can do. So it will be capital R into H equal to small r into small letter h minus capital R into small letter h equal to small r into capital H. So it will be equal to, can take h common outside, is directly right. So capital H equal to, take small r to the denominator. So capital H equal to small r into small h minus capital R into h divided by small letter r. Equation number 1. Now in this case, in this one now we'll take small letter h common outside. So it will be small letter h when you take common outside, small r minus capital R divided by small r. Therefore we'll conclude that one capital H equal to small h into small r minus capital R divided by small r. Take as equation number 1. Now semi-vertical angle. In the given data, at first I will just write that one also. Semi-vertical angle is angle CAF. That is a semi-vertical angle. So semi-vertical angle, here I will write. Semi-vertical angle. That is angle CAF equal to alpha. Angle CAF is equal to alpha. Of a cone actually, no? Of a cone. Now here we will take the right angle triangle AFC. In that right angle triangle AFC, we want to know that what is tan alpha. So here FC is actually small letter r and AF is small letter h. So tan alpha equal to, in right triangle AFC, tan alpha equal to, now opposite side divided by adjacent side. Opposite side is FC divided by adjacent side is AF equal to R divided by H. That is equation number 2. Later we need that one. As once more I'll conclude that one. There is tan alpha equal to R by H. Equation number 2, or it can be modified in another form also. R equal to H tan alpha. So that one, no, later substitution we'll use that one for later substitution. Now we want to find out the volume of the cylinder. Volume of cylinder. V equal to pi r squared. Radius of the cylinder is actually pi capital R squared into capital H. Now we'll substitute 1 in 4. I'll give the equation, otherwise 1 directly. So in the place of capital H we'll substitute. So it will become V equal to pi into capital R squared. Instead of capital H we'll substitute small h into small r minus capital R divided by small r. Here variable constants are small h and small r. Variable is capital R squared. So I'll take that variable to the variable inside the bracket for avoiding the product rule. So pi h by r will keep outside because they are constants. Now capital R squared we'll take inside now. So when you multiply with capital R squared into small r, that is capital R squared into small r, then again minus capital R squared into r, capital R will be capital R cube. That is the volume. I'll write here from where we got from 1. From 1 we got. So now we got the volume of the cylinder as V equal to, write the final value, pi h by r, pi h by small r, into capital R squared into small r minus r cube. That is equation number 4. Now we are differentiating with respect to capital R, because capital R is the only variable. Differentiating with respect to capital R. So dV by dr equal to pi h by r. Differentiation of capital R squared is 2r. Small r is a constant, otherwise small r is a constant. Write it like first. Differentiation of capital R squared is 2r minus differentiation of r cube is 3r squared. Now that will be equal to pi h by r into 2 capital R into small r minus 3r squared. That one I'll name as equation number 5. Now we'll write for maximum or minima. For maximum minima, dV by dr equal to 0. That is pi h by small r into 2 capital R into small r minus 3r squared equal to 0. So when you cross multiply pi h by r, when you take it to the other side, it will become 0 into small r by pi h. It will become 0. So the term left out will be So the term left out will be 2 capital R into small r minus 3r squared equal to 0. Take r common, capital R common outside. 2 into small r minus 3 capital R equal to 0. So you know that one. Either capital R equal to 0 or 2r minus capital R we don't want, actually that is a constant. So 2r minus 3r equal to 0. That is, we want to find out, no, capital R is not the constant, small r is the constant actually. So capital R equal to 0, radius cannot be 0. So we'll reject it. Rejected. Now here we want to find out capital R. So 2 small r equal to 3 into capital R, or capital R equal to 2 by 3 small r. That is equation number 6. Now we'll do the second derivative. D squared V by dr squared. D squared V by dr squared. Equal to D by dr of dV by dr. That is d by dr of pi h by small r into 2 capital R into small r minus 3r squared. So when you do the differentiation, in bracket I'll just write from 5. From 5, no? From 5 we substituted for dV by dr. So it will be equal to pi h by r into 2 small r is a 2r is a constant. Differentiation of capital R is 1 because we are differentiating with respect to r. So 2 small r minus 3 into 2 capital R. Differentiation of r squared is 2r. So that will be equal to pi h by r into 2r minus 6 capital R. 6 into r. That is equation number, that is directly, otherwise name as just 7. Either you can name it as 7 or directly substitute. So d squared v by dr squared at capital R equal to 2 by 3 small r equal to pi h by r into 2r minus 6 into capital R is 2 by 3 small r. Now that will be equal to 3 and 6 will be cancelled. It will become 2. 3 and 6 will be cancelled 2. So it will become 2r minus 4r. So pi h by r into 2r minus 4r. Right hand sides. It is equal to pi h by r into 2r minus 4r. So 2r minus 4r is a negative value. So it will become pi h by r into minus 2r. If you want to cancel, otherwise we'll write negative less than 0. Therefore, now since we got the negative value d squared v by dr squared is negative, we'll say that therefore r equal to 2 by 3 r is a point of local maximum. Therefore, the volume of the cylinder is maximum. At capital R equal to 2r by 3, 2 by 3r. But they told you to find out show that the height of a cylinder of greatest volume which can be inscribed in a right circular cone of height h and semi-vertical angle alpha is 1/3 that of the. So you have to prove that the height of the cone is 1/3, that height of the cylinder is 1/3 that of the cone. So we'll substitute that on this value. Substitute capital R equal to 2 by 3 small r in equation number 1. Equation number 1 was actually capital H equal to small h into small r minus capital R by small r. So we'll substitute. Small h will keep like that minus, small h into small r minus the place of capital R 2 by 3 small r divided by small r. So it will be equal to small h into 3r minus 2r divided by, when you take that LCM 3 and r, so divide by 3r. Directly I am taking. LCM is 3, then whole divide by r, 3r. So it will become equal to h into r divided by 3r. So that is h by 3. So you prove that height of the cylinder is 1/3 height of the cone. So capital H equal to h by 3. That is, one time I'll write that is height of the cylinder is equation number 5, 6, 7 I'll give. I'll conclude that one, that is height of the cylinder is one by 3 height of cone. By 3 height of cone. Now we want to find the greatest volume actually. So we want to prove that volume of the cylinder is 4 by 27. So we'll substitute capital H equal to small h by 3 or capital R equal to 2 by 3 small r in equation number 4. Therefore, volume of cylinder. Volume of cylinder, we want to prove that volume of cylinder is maximum. Now, volume of cylinder. V equal to We'll substitute in pi r squared h. That will be easy for you. So volume of cylinder is pi capital R squared into capital H. Capital H value you know, h by 3. So it will be equal to pi into, in the place of capital R squared you will substitute 2 by 3r. So in this one, pi into capital R squared is 2 by 3r from 6. 2 by 3r, the whole square. Then capital H is h by 3 from 7. I'll write here from 6 and 7. So it will be equal to pi into 4r squared divided by 3 3s are 9 into h by 3. That is 4 pi divided by 9 3s are 27. 4 by 27 pi. Now you need the answer in terms of h cube tan squared alpha. So what we'll do means now replace small letter r by h tan alpha. Because from equation 3 you can see that one from 3. And write pi 4 pi divided by 27 into, in the place of small r squared I'll write h tan alpha the whole square into h. So 4 into pi, 9 3s are 27. In the place of small r squared you wrote h tan alpha the whole square into h. I'll write here from 3 actually. From 3 r equal to h tan alpha. So now when you will open the bracket, you will get the answer v equal to. So v equal to 4 pi divided by 27 into h squared tan squared alpha into h equal to 4 by 27 pi h squared into h is h cube tan squared alpha. That is the maximum volume of the cylinder. So I'll write the greatest volume of cylinder. Greatest volume of cylinder. That can be inscribed in a cone of height h. And radius r. Is v equal to 4 by 27 pi h cube tan squared alpha. That is the answer.